Hi everyone, welcome to the session on Agile Methodology CS22071 presented by R. Samundi, Assistant Professor of Computer Science and Engineering. Today we are going to see Unit 3 Agility and Knowledge Management. In that Unit 3, we'll see the Agile Information System. So, first we have to understand what is a Agile information system. An Agile information system is built to adapt quickly to change. It delivers small, safe updates often and learns from feedback. So, think of this system like a smartphone app that updates every week, small improvements, quick fixes, and always listening to what users say. It emphasizes flexibility through the modular design and automation. This lets team evolve features without breaking the whole system. Imagine a Lego house. You can add or remove one block without disturbing the whole structure. That's a modular design, and automation makes it even smoother. Agile means short cycle, tight feedback, and continuous improvement. The goal is faster value delivery without lower risk. Instead of building the old car and then showing it, Agile is like showing one part at a time, get feedback, improve, and reduce the chance of failure. An Agile information system aligns tech choice with business outcomes and user needs. Value is measured by adoption, reliability, speed to market. At the end of the day, it's not about the fancy technology. It is about what user love, what works reliably, and how fast we can bring it to them. In next slide, we'll see why do we need Agile information system. So first one is rapid response. Markets, regulation and technology change rapidly and unpredictability. Agile information system helps you respond in weeks, not quarters. So, the Agile information system is like a fast car in a traffic jam. It helps you react quickly to sudden changes, whether in market or rules or technology. So it takes weeks, not a quarters. And next point, it reduces the risk. It reduces time to market and the cost of late changes. Small batches mean faster learning and fewer failures. By delivering small steps, Agile information system lowers the cost of mistakes and turns the risk into quick lesson. So that is small batches, fewer failures. And third point, experimentations. It enables experimentation and is safe to try ideas. Bad ideas fail fast. Good ideas scale quickly. So think of Agile information system like a safe playground. You can test ideas without fear, drop the bad ones and grow the best one faster. That is fail fast, scale fast. And fourth one, organizational resilience. It builds organizational resilience and optionality. You can pivot without re-architecting from scratch. Agile information system makes the organizations like a bamboo. It is flexible, strong and able to bend without breaking when conditions change. That is bend. Don't break the overall system. In next slide, we are going to see what are the core principles of Agile information systems. Here, number one is the iterative delivery. Ship working software early and often. Short cycles create a rapid feedback and lower a risk. Instead of waiting months for one big launch, we deliver small steps like serving odd snacks instead of one giant meal. Deliver early, deliver often. And next principle, tight feedback loops. From user and telemetry, data, not opinions, drives the next improvement. Here, decisions are not based on guesses. Real user data tell us what to fix or improve next. Data over opinion. And third principle, simplicity first. To avoid over engineering, build just enough now. Keep options open for later. So don't build a rocket when all you need is a bicycle. Keep it simple and expand only when necessary. So build what's needed, not everything. And the next point, continuous improvement. With the retrospective and metrics, teams refine process, quality and flow every sprint. Every cycle we stop, reflect and improve, just like athletes reviewing each game to play better in the context one. Always improving every sprint. In next slide, we'll see the topic is architecture for agility. Here the first one is the modular or microservice with a clear boundaries and contact. Loose coupling allows independent changes and releases. Think of microservice like different shops in a mall. Each runs independently, but together they create a full experience. So independent pieces makes a strong whole. And next one is API first and event driven. Designs enable integration at speed. Publish, subscribe, decouples producer from consumers. APIs are like bridges. They connect systems quickly. Event driven system design make sure one change does not block the whole flow. So connect fast and react smart. And next one is the cloud native. With containers and auto scaling on Kubernetes, elastic capacity matches demand without manual effort. Cloud native is like electricity. You use more when needed and pay only for what you use. It grows automatically with demand. Scale as you go. Next one is the data lake and lakehouse. It supports the schema, evaluation and reuse. Shared data products avoid point-to-point chores. So data lakes are like a central libraries, organized, evolving and reusable instead of messy piles of separate files. So one source, many users. In next slide, we'll see the process and ways of working. Here the Scrum or Kanban, backlog, sprint, a review and retro cadence. Transparency and rhythm keep teams aligned and focused. Scrum and Kanban gives us the rhythm, that is plan. First we have to plan and act. Based on the plan we have to act. After that we have to do the review. Again we have to improve based on the review, like the steady beat that keeps the whole team in synchronization. Stay in rhythm, stay aligned. And next one is the DevOps and CI/CD. Automate, build, test, and deploy. Frequent reliable releases reduce change failure rate. That CI/CD is like an assembly line. Every change is built, tested, and delivered automatically at reducing failures. Automate to accelerate. Infrastructure as code. Terraform or Ansible for parity. Environments are reproducible, versioned, and auditable. With the infrastructure as code, we treat servers like code, consistent, repeatable, and always traceable. So, code your infrastructure. And last one is automated test. That is unit, contract, end to end as safety nets. Quality is built in, not inspected in at the end. Automated tests are the safety net, catching errors early so quality is baked in, not checked in last minute. So quality from the start. In next slide, we see the people's roles and lightweight governance. Here, cross-functionals and squads. The developments, quality assurance, ops, data and security together. That is cross-functional squads. Fewer hands-off, faster flow and shared accountability. Instead of passing the ball from one team to another, all roles work together like one squad, faster, smoother and more accountable. So, one team shared the ownership between all among the members of the team. Clear roles include product owner, tech lead, engineers, analyst. Clear ownership speeds decision and reduces churn. When everyone knows their role, there is no confusion. Decisions are faster and less time is wasted. So clarity speeds action. The lightweight RASI and decision records guide choices just enough process to align without slowing down. Lightweight RASI is about balance, enough structure to guide decisions, but not so much that it slows progress. Guide, but don't burden the team. Living documentations, API specs, runbooks, playbooks, knowledge stays current and reduces onboarding time. Living documentation is like a GPS, always updated, easy to follow, and saves new people from getting lost. Docs that have lives, teams that move. In next slide, we will see what are the data and analytic agility. Start from streaming plus batch, that is reliable ingestion with checks and lineage. Think of streaming and batch like water pipes, real-time flow and stored buckets. Both ensure data arrives clean, checked and traceable. So streaming plus batch means the data flows and how the data can be trusted. Next one, feature store, that is centralized version features for models. A feature store is like a well organized pantry. All ingredients, features are versioned, reusable, and ready for your machine learning recipe. Features once, models many. Next one is MLOps. Train, deploy, monitor models continuously. MLOps like a DevOps for AI. It keeps model trained, deployed and monitored, so they stay accurate over time. AI that runs reliability. And the last one is self-serve analytics. Catalog, data for team, reuse and insights. Self-serve analytics is like a digital library. Teams can find and use data easily without waiting on others. So, insight on demands. In next slide, we will see integration and legacy modernization. The number one, API gateway and service registry. API gateway and service registry and rate limiting at the edge. Consistent entry points improve control and observability. And API gateway is like the main entrance of the building, one secure entry point that makes monitoring and control much easier. That is one door, full control. And second one is integration patterns. Choose choreography versus orchestration intentionally. Even scale autonomy. Workflows centralize complex steps. Integration patterns are like dance style. Choreography gives freedom, orchestration gives structure, so both must be chosen carefully. Third one is strangler pattern. Replace monolith piece by piece, new capabilities, wrap and gradually return legacy parts. The strangler pattern works like a replacing world wiring room by room, modernizing gradually without shutting everything down. So, replacing step by step is called as the strangler pattern. And then last one is open standards. Prefer open standards to avoid vendor lock-in. Portability keeps strategic opinions open over time. Open standards are like using universal chargers. They ensure flexibility and prevent dependency on one vendor. So, stay open and stay free. Next, we'll see the security, reliability, observability and measurement. Here, the DevSecOps, that is the shift left security, least privilege and secrets management, automated scans and policies catch issues early. So, dev security operationals means baking security in from the start, catching the problem early with automations instead of waiting until the end. Security from the day one. Next one, reliability via SLOS, error budgets, resilience patterns, auto scaling, circuit breakers, and DR limit blast radius. Reliability is about keeping system up even the things go wrong. Auto scaling backups and smart fail-safe protect user. So always on, always ready. Third one is observability. Deep observability with logs, metrics and traces. So faster detections and MTTR through actionable telemetry. So observability is like giving your system X-ray visions with logs and metrics. You see the issues fast and fix them before the user even notice. See more, fix faster. And fourth point is DO or a matrix. Measure agility with DO or a matrix and product metrics. Gives result to prioritize improvements and investments. We can't improve what we don't measure. So, DO or a matrix tracks the engineering performance while product metrics shows the business and user impact. Measure to improve. The DO or a metrics are deployment frequency, lead time for changes, change failure rate, and time to restore the service. The DO or a metrics are like the heartbeat of the DevOps. They tell us how fast we deliver, how often we fail, and how quickly we recover. That is speed, stability, recovery. And the fifth one is the product metrics, that is user adoptions, feature usage, and customer satisfactions, business value deliver, and time to market. So the product metrics shift focus from just delivery to impact. Are users adapting? Are they satisfied? And are we delivering the real business value from output to outcomes? So these are the agile information systems. Now you will answer the one MCQ question. After that, we will wind up. Thank you.